Good morning, my dear student. My name is Twayna. I am currently available at the Hamlet Tuition Center, Brahmatal, Kathmandu, and Kumudini Kunja Secondary School, Kalimati, Kathmandu. My dear students of grade 8, this is your science class, and in our science class from our last class, we have been discussing about the chapter sound. Okay, and after our previous class, we discussed some of the characteristics of sound, isn't it? Especially the wave characteristics of sound. If you remember this slide, this is the slide we discussed in our previous class. Yes, if you remember this slide, well, sound wave is a mechanical wave and which mostly forms longitudinal wave, not transverse. It forms longitudinal wave. And sound also forms transverse wave, but only in liquid and solid medium. Yes, well, longitudinal wave means the wave in which particles vibrate in the same direction as the transmission of energy. And since it requires material medium, it requires particles or vibration of molecules to transmit. It cannot transmit in space or vacuum, isn't it? And then we also discussed the nature of longitudinal wave. A longitudinal wave contains two parts: compression and rarefaction. Okay, now let us discuss further the first point being a complete wave. Well, a wave consisting of one compression and one rarefaction is known as one complete wave. See, from here, compression and rarefaction, up to here it forms one complete wave. Okay, that means what happens, suppose this is a particle. Yes, the particle is at this position. Let me draw a circle at least. Okay, suppose this is a particle, isn't it? When some kind of force is acting in this direction, like let's say force is acting in this direction, or energy is being applied in this direction. Yes, okay, let's say that energy is sound energy, you can say. Okay, sound energy is applied in this direction. Then what happens is, because of that energy, the ball moves here, isn't it? The ball moves here, or better to say, this is actual position. Yes, let me mark the position here, I will need it. Okay, this is the position of ball. Okay, because of energy, the ball displaces in the direction of energy. Yes, and then here, if there was another molecule, let's say here is another molecule. Yes, so the ball moves this way, and when it hits the molecule, what happens? It comes back, whereas the molecule moves, isn't it? So when it comes back, it does not stop at its original position. This does not occur. What happens when you apply energy or apply force? The ball or the particle moves in the direction of force. Okay, when it hit another body, then it comes back, but it does not stop at its old position. It displaces equally in opposite direction. Okay, it displaces equally in opposite direction. Then again it gains some force, and then it comes back to its position. Got it? So when this molecule is moving in the direction of force, it forms compression. See, it forms compression. Okay, these two molecules are compact, isn't it? But when this molecule moves in the opposite direction, it forms rarefaction. Okay, it forms rarefaction, and after that again it comes back to its original position, maintaining the original distance between these two particles. Okay, then one wave is completed. Okay, that is why one complete wave consists of both compression and rarefaction. Okay, one complete wave consists of both compression and rarefaction. Understood? Yes. Now how many waves are formed in this particular example? You can count only C or only R, but if you count both, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if you count like this, then you might say there are 10 waves. No, that's not true. That's not true. There are 5 compression and 5 rarefaction, means there are 5 complete wave. Okay, in this particular example there are 5 complete wave. Understood? Okay, now let's discuss magnitude. Okay, sorry, amplitude. Amplitude means, I told you this is a particle, yes? So by applying force, it displaces from its mean position. This is the mean position. Due to application of force, it displaces certain distance. Okay, so how long will it move? How far will it move from its original position? That depends on amount of energy being applied. If you apply more energy, then it might go even farther, isn't it? If you apply very small amount of energy, then it might just go little bit and then come back and then go to its original position. If you apply more force, it might go like this. Sorry. Okay, it might go like this, isn't it? If you apply a lot of force, then it might go like this. First it comes here and then it comes there and then again back to its position. So how far will it move from its original position, from its mean position? That depends on amount of force or amount of energy being applied. And how far will it move? That is known as amplitude. Okay, how far a particle move away from its mean position is known as amplitude. Okay, so the maximum displacement, read the note, the maximum displacement of a particle from its mean position is known as amplitude of a wave. It is determined by intensity of energy of the wave. That means how much energy is present in the wave, that determines it. That is, stronger the wave is, higher is the amplitude, and SI unit of amplitude is meter. Okay, any confusion up here? A complete wave and amplitude? Okay, if there are no confusion, then we shall go to next topic. Okay, number 3, frequency. Well, frequency means how many waves are formed in 1 second time. That is called frequency. Okay, suppose that in this particular example, this all takes 1 second time. Okay, to form this all wave, this much wave, it takes 1 second time. So how many waves are being formed by this source of sound? We have already counted it. Yes, it has 5 complete waves. So in this particular case, 5 complete waves are formed in 1 second time. So what will its frequency be? 5. Okay, in 1 second time there are 5 waves are formed. So its frequency is 5 and SI unit is hertz. So its frequency would be 5 hertz. If a particular source of sound produces 2000 complete wave in 1 second time, then its frequency would be 2000 hertz. Okay, 2000 complete wave means 2000 compression and 2000 rarefaction. Okay, and the larger unit of frequency is kilohertz. Kilo means 1000. Kilo means 1000. So 1 kilohertz means 1000 hertz. Okay, and larger unit than kilo is mega. Mega means million. Okay, mega means million. So 1 megahertz means 1 million hertz. Okay, 1 megahertz means 1 million hertz. Understood? This is 1000 times of 1000. Okay, mega means 1000 times of 1000. तर बाप का भी बाप हुमे भन्छन् हैन. ओके, हर्ज भनेको छोरा भयो, किलो हर्ज भनेको बाउ भयो, मेगा हर्ज भनेको बाउको पनि बाउ, बाजे के. त्यसरी बुझ है ओके हर्ज का बाप किलो हर्ज का बाप मेगा हर्ज तेरा बाप का भी बाप हैन त okay anyway you understand what is 1 kilohertz and 1 megahertz now you will not forget it I know it okay next one is time period so time period basically means how long does one complete wave takes the time to form okay how long time does one complete wave or one cycle of wave takes to complete it or to form yes that is known as time period okay so basically to find out time period you have to take inverse of frequency okay because frequency means number of wave formed in 1 second time isn't it so if in 1 second time 10 waves can be formed then use the unitary method how long time will it take by one wave it is 1 by 10 second yes if 5 waves are formed in 1 second time then one single wave takes 1 by 5 second time to complete isn't it it is very simple that's why mathematically time period is equals to 1 upon frequency okay don't forget that okay next term you need to know is wavelength see the term suggests that length of a wave or you can say how long distance will a complete wave one complete wave travel okay how long distance will one complete wave travel that is known as wavelength the distance traveled by one wave in one complete cycle is called wavelength in this particular case compression starts from here and rarefaction ends to here yes so in one complete wave energy travels a distance from this point to this point yes during a formation of one complete wave energy started its journey from here and it ends here that means this much distance is covered by energy in one complete cycle and that is known as wavelength length of a wave basically it is length of a wave okay see the distance traveled by wave in one complete cycle is called wavelength okay to measure wavelength there are three alternatives either you measure a total distance or total length of compression and rarefaction yes that is the original wavelength or you can also measure the distance between two consecutive compression the distance from one compression to another compression that can also be taken as wavelength okay because basically that would be equal to a total distance between C and R yes or alternately you can also take a total distance between one rarefaction to another rarefaction okay that way also you can take wavelength but original method is to take the distance of one compression and one rarefaction okay now here you don't need to write this crest and trough okay the distance between consecutive compression or consecutive rarefaction okay wavelength or wavelength is also measured as the distance between consecutive compression or consecutive rarefaction and SI unit of wavelength is also meter length means meter okay length means meter yes okay now next one and the last one is wave velocity velocity means speed isn't it what distance is traveled by wave in 1 second time is known as wave velocity okay what distance is traveled by the wave in 1 second time is known as wave velocity okay generally what do you mean by velocity it means distance traveled by a moving object in 1 second time is known as velocity now wave velocity means distance traveled by wave in 1 second time is wave velocity. Okay, just like normal velocity, its SI unit is also meter per second. And in case of wave, you have special formula to calculate velocity, that is V equals to F into lambda. Okay, V equals to F into lambda. Yes, here V stands for wave velocity, F stands for frequency, and lambda stands for wavelength. Understood? Okay, what terms are studied today? What properties of wave are discussed today? Well, first of all, a complete wave, isn't it? You know that a wave consists of compression and rarefaction. Now, one compression and one rarefaction comprises one complete wave. Just a compression is not complete wave. Just a rarefaction is also not complete wave. Okay, one compression and one rarefaction forms a complete wave. And next one is amplitude. Amplitude means from the mean position, how much displacement occur after vibrating molecules, that is amplitude. Okay, or maximum displacement of particle from its mean position, and it is affected by amount of energy possessed by the wave. Okay, and next term you discussed was frequency. Frequency means how many waves are formed in 1 second time. How many waves are formed in 1 second time, that is frequency. Okay, and SI unit of frequency is hertz. Yes, and larger unit of frequencies are kilohertz and megahertz. And next term we discussed today was time period. Yes, so how long time does one complete cycle of wave take to complete? Okay, how long time will a wave completes? That is known as time period. Yes, and mathematically time period is just inverse of frequency, just opposite of frequency. Okay, and next term was wavelength. Wavelength means the distance traveled by wave in one complete cycle. The distance traveled by wave in one complete cycle. And wave velocity means distance traveled by wave in 1 second time. Okay, see the differences between these two terms. Wavelength means distance traveled by wave in one complete cycle. Distance traveled by wave in one complete cycle. And wave velocity, distance traveled by wave in 1 second time. Only that much is difference. Okay, and what is the formula to calculate wave velocity? It is frequency into wavelength, that means F into lambda. To calculate velocity of sound wave, you need two data, that means frequency and lambda. Understood? Okay, if you do not have any question up to this point, then we can go to doing numerical problems. Okay, the first one I will show you by doing. Okay, the second and third, let's see if they are too difficult, I'll do, otherwise you have to do on your own. Okay, instead of answer, solution. Okay, what are the given information? While doing numerical, you always have to give given information. Okay, if the frequency of sound is 100 hertz, if the frequency of sound is 100 hertz, that is frequency is given, frequency F is equals to 100 hertz, and then what is given, and its wavelength is 3.3 meter. Okay, wavelength means lambda. Yes, how to write lambda? Okay, lambda, wavelength lambda is equals to 3.3 meter. Okay, now what you need to find, velocity of sound, that means V equals to what? As we know, okay, what is the formula of velocity? V equals to F multiplied by lambda. Okay, lambda. or V, we don't know V, do we? Okay, F 100 Hz multiplied by lambda 3.3 meter, or V is equals to, multiply this, you will get 330. Now what is SI unit of V? Meter per second. Okay, how do you get meter per second? Is Hertz. Hertz means per cycle, cycle per second, isn't it? 100 cycle per second, so it is per second, divide by second. Here you have meter, so it will give you meter per second. Now give conclusion. Therefore velocity of the sound is 330 meter per second. Any confusion? Okay, now can you do next question or not? Let's see. A sound wave of 15 kilohertz. Here you are given frequency as 15 kilohertz, and you need to convert it into SI unit, that means hertz. What you should do? Multiply it by 1000, and then wavelength is given. Now you need to calculate speed of sound. Okay, can you do, or I have to do it? Okay, let's see. Solution. First you need to take given information. What information are given? You are given frequency. Frequency equals to 15 kilohertz, and 15 kilohertz means 15 times 1000 hertz. Okay, so it gives you 15,000 hertz. This much you have to do. And next, wavelength is given. Lambda equals to 0.022 meter. So it's already in SI system, so you do not need to convert it. Okay, every time I say do not, I want to eat donut. Do you have? Okay, next time you come to school, please bring donut, okay, as a gift to me. Okay, speed equals to what? As we know, you have special formula, P equals to F into lambda. Yes? Okay, or V, we do not know, F 15,000 hertz multiplied by lambda 0.022 meter, or V is equals to, okay, what will be the product? Okay, need to multiply 15,000 into 0.22. 15,000 into 0.022. Okay, it gives you 330. Once again, 330 meter per second. Give conclusion. Therefore, speed of the sound wave is 330 meter per second. This one. Now can you do the third one or not? See, calculate the frequency of sound wave. Now frequency is not given to you. In previous two questions, frequency was given. You needed to calculate velocity. But now you need to calculate frequency when speed is given and wavelength is also given. Okay, do you think you can do it? Okay, I hope you must be able to do it. Let me give you just a hint. Okay, like you would use the formula V equals to F into lambda. Yes, or in next step, what you do, in previous question you do not put the value of V, yes, but now you know the value of V. Put the value of V. 350 meter per second is equals to F you do not have, and lambda you have it, 35 meter. Now can you cross multiply it or not? Yes, you can cross multiply. If you have studied the rules in mathematics, then you can divide both terms, both side by 35, isn't it? Let me make the fraction here. Okay, or okay, I've divided the left side, left side, the left hand side. I've divided the left hand side by 35, yes, and equals to right side also you need to divide it by 35. Okay, let me divide it. Okay, okay, it is something like this, yes, it is something like this. So you can, according to the rules of mathematics, you can divide both sides by same number, isn't it? So in this side, these two terms will simply cross out, they simply are cancelled out. 35 times 1, 35 times 1, and here you can cancel them in terms that 35 times 1 is 35 and 35 times 10 is 350. Yes, so what you get in next step is, here you get 10 meter per second is equals to, there you get F, yes, and meter can also be cancelled out on both sides, isn't it? Yes, that means you get here 10 cycles per second, and this cycles per second can also be replaced with hertz. Okay, finally you get your answer in hertz. Okay, I haven't written the given information and orders. Okay, you do that on your own. You understand this or not? Yes. Okay, that much for today. Okay, now let me copy some questions for you as your assignment. Okay, let me pause the video. Okay, take out these 3 questions as your assignment. Number 1, the frequency of a sound wave is 50 Hz and its wavelength is 6.6 meter. Calculate the calculate the speed of sound. Number 2, the speed of sound in air is 332 meter per second. If the frequency of sound is 30 Hz, calculate the wavelength. And number 3, the speed of a sound is 330 meter per second and its wavelength is 8.25 meter respectively. Calculate the frequency of the sound wave. Okay, I hope you can do all these 3 questions. Yes. Okay, if you have any questions, if you have any confusion regarding what we have studied today, then you can always call me, or you can contact me through Messenger, or you can contact me through Viber. Okay, that's all for today. Thank you, class.